Alright, today we're talking about section 10.9, which is circumference and arc length. So some of this should be review from chapter 9, and as we go through this, I do want to remind you just to keep your answers in exact form, so keep pi in your answers. Alright, so to get started, we're going to talk about circumference. We should know the formula for circumference. That is just pi times diameter, or 2 pi r. Okay, so that should be familiar. So the first example says, if a wheel has a radius of 6, how far does it travel if it rotates 100 times? Alright, so if we're looking at a wheel here, and our radius is 6, we want to know how far it travels if it rotates 100 times. So if it rotates just once, okay, that would just be the measure of the circumference one time. So here, our circumference equals the diameter, which would be 12 times pi. So then to see how far it travels after 100 rotations, we're just going to multiply that by 100, which will give us 1200 pi. Okay? And then next we have the length of an arc. Okay, so length of AB. Again, this part should be review. Okay, so if we have some circle and our arc, okay, we want to know the length of the arc. We know that that is going to be the measure of the arc divided by 360 degrees times our circumference. Alright, because this is just a fraction of the whole circumference of the circle. So, for example, what is the length of a 40-degree arc in a circle with a 10-foot radius? So let's draw a circle here, and we have that the arc measures 40 degrees and our radius is 10. Alright, so we're just going to use our formula. So we have 40 degrees divided by 360 times our circumference, which is 20 pi, so diameter is 20. And when we simplify that, we'll get 20 pi divided by 9. Okay. Alright, the next question says, the figure is a square with a semicircle on top, and we want to know what the perimeter is of this figure. So we know that this is a square down here, so we can mark that these are all congruent. Okay, and then we have the semicircle on top. So if we want to know the perimeter, we can first start by finding the circumference of what the whole circle would be. So the circumference of the circle, the whole circle, would be 12 pi. Okay, because since this is a square, we know that this side also equals 12, so the diameter of our circle is 12. So the circumference of our semicircle is just going to be half of that, which would be 6 pi. So then to figure out the perimeter of the figure, we're going to add all of our 12s. So we have 12 3 times plus the circumference of our semicircle, which will simplify to 36 pi. Alright, the next example here, very similar. We have a rectangle with semicircles on each end, and we want to know the perimeter. So first you should notice that this side will also be 400. And over here we have 100, because this is a rectangle. And then if we look at these two semicircles, we should notice right away that both of them together will make up a full circle, so we can just find the circumference of a full circle with a diameter of 100. So our circumference here is just going to be 100 pi. Okay, so then our perimeter is going to be 400 plus 400 plus our 100 pi from our semicircles, which will give us an answer of 800 plus 100 pi. Okay, so again, leave our answers in exact form. Alright, the next question, again, similar to the last two, but a little bit more challenging this time. So our inside figure here is a square, And again, I want to know the perimeter of it. So since our inside figure is a square, we know we have 6s here. Okay, and then let's look at these corner pieces. So we can see here that this angle is going to be 90 degrees, right, because this is a square. So then if we look at all 4 of these, we'll notice that since each one is 90, all 4 of them put together would make up one circle with a radius of 2. Okay, so then our circumference of this circle is just going to be 4 pi. Alright, and then we want to know the perimeter of this figure, so since we have this square here, we know that these lengths are going to be 6 as well. So our perimeter is going to equal 4 times 6, which is 24, plus our circumference of our circle, our little corner pieces, which was 4 pi, and that is our final answer. Okay, number 6, I want you to pause the video and try this one on your own. Okay, so what you should have noticed is that these are actually concentric semicircles. So if you were wondering if that's true, that is true. These are concentric semicircles. Okay. So then we know that this is going to be 6 here, and then we know this piece will be 4. Alright, so then we can see that if our whole diameter of our big circle here is going to be 14. Alright, but I do want to go back and I want to start with the little circle here. Okay, so I want to find the circumference of the little circle. So my circumference of little circle, and that will be 1/2 times 6 pi, because our diameter of our little circle is 6. Okay, which will give us 3 pi. And then I want to find the circumference of the big circle. Okay, this is going to be 1/2 times 14 pi, which equals 7 pi, right, because that was our big diameter. Then the perimeter of the whole figure is going to be 4 plus 4, so our 2 little straight edges right here, plus 3 pi plus 7 pi, the 2 pieces of each circle, which will give us 8 plus 10 pi. Okay. Alright, so moving on to number 7. So now we're going to be using our length formula. So this says the length of an arc is 6 pi with a diameter of 15, and we want to know what the measure of the arc is. Okay. So just remember that the length of an arc equals the measure of the arc divided by 360 times the circumference, right? That's just review. And then let's draw our picture here. So we have our circle, and then we have some arc here that measures 6 pi. Our diameter is 15. Okay, so we know that the length already is 6 pi. So we know the length. We don't know the measure of the arc. And then we can figure out the circumference using our diameter, so that would be 15 pi. So here we want to solve for the measure of the arc. So we can do that by multiplying by 360 over 15 pi on both sides. And when we simplify that out, our pi's here will cancel, and we will end up with 144 degrees equals the measure of the arc. Alright. And then our last problem here. So this says the arc, or the area of a sector is 30 pi with a circumference of 20 pi. And we want to know the measure of the arc again here. So I'll draw my circle. So we have sum area of a sector equals 30 pi. Okay, so area of a sector, again, is reviews from chapter 9, so we will write that the area of a sector equals the measure of the arc over 360, and this time we're going to multiply this by the area of the whole circle, which we'll call is pi r squared, because the area of a sector is just a fraction of the whole circle. Alright, so from our problem we already know the area is 30 pi equals the measure of our arc divided by 360. So here we need to figure out what that area is. So we're going to use that our circumference is 20 pi to figure that out. Okay, so we know circumference equals 20 pi, so then we know our diameter equals 20, so then our radius equals 10, so then our area equals our radius squared times pi. Okay, so we can add that into our equation here. So we have 100 pi. Alright, so we have 30 pi equals the measure of our arc over 360 times 100 pi. And we're going to simplify that just like we did before. And when we do that, we will come up with 108 degrees equals the measure of our arc. Okay, and that concludes our 10.9 notes.